Hello, everybody. I want to talk about this problem because there's a bunch of interesting steps that are very important to it. The first one, it says create a random 2000-digit number, find the 14 adjacent digits that have the greatest product. So we want to first create a 2000-digit number, which you can't really do. It's not an int or a double, obviously. You want to find 14 adjacent numbers. So if like it's 2000 digits, you just, if you have like lots and lots of digits, like if this is your number, right? 14 adjacent digits would be like any 14 or 13 that are like this, right? So if it's 13 adjacent digits, 14 adjacent doesn't really matter, but like any of those or however many, just count 14 of them, and that's your adjacent digit. So, and we want to multiply all those and see what number we get. So which is the biggest? So for instance, let's say I had this number and it's 9845921, and you want two adjacent digits. So the biggest two adjacent digits are 9 and 8, right? So if you go through it, you check 9 8, then 8 4, then 4 5, then 5 9, then 9 2, then 2 1, and you multiply them out and you see which is the greatest product. Now it looks like it's going to be two loops, and so we're going to talk about that. Now before anything else, the question is, well, it's nice that I have this, but how do I create a 2000-digit number? So the simplest and basic approach would be create don't create an actual number, just create an array that's of size 2000 and just consider that a number. So for instance, if I were to say that I have an array and it's going to be of new int and the size is going to be 2000, then all I need to do is fill it in up until r dot length. I'm going to fill it in and I'm going to say that r of I equals, and now I'm going to put in here a RND dot, the next int, and we'll say 10. So we should probably just set it up so that r of 0 is a 1, because if it were, or some other value, it doesn't really matter. I'm just going to say rand dot next int, and it's going to be up until 10, but up until 9 plus 9. So it's 0 through 8 plus 1. So that's 1 to 9. So this one can be afterwards, it can be that though. So I'm going to set it up so it's just a random number that's not a 0. And then the rest are just going to be random digits. So this would be perfectly fine to set up our random 2000-digit number. It's not really a number, but it's perfectly fine to be something like this. Now, another way to do it, so I'm just going to approach number one. Okay. Approach number two, to create my really big number, approach number two is what you'd have to be a char array, because then I can kind of convert it to a string after I do that. So if I create a char and I call it number and I say new char, and it's going to be of size 2000, and I'm going to just put some number in the beginning, like number of 0 is going to be equal to like a 1 as a character. Just pick any number, it doesn't really make a difference, because the first position just can't be a 0. And then I'm going to do my for loop going from 1, because that's filled in, up until 2000. And now I'm going to say that number of I, the ith position, is going to be converted to a char by getting a start with the character 0. This is one way to do it. And then I'm going to do rnd dot next int, and I'm going to pick anything 0 through 9 and fill it in. So what's happening over here is we're taking character 0 and we're moving it over some number of spots, which, because I don't know what position the character, what value 0 has. In other words, it could be number 79 in the list of characters, but it doesn't matter because I'm going to move it over some number of spots, convert that to a character, which will definitely be a number because it will be 0, 1, 2, 3, etc. It will definitely be a number. And then I'm going to convert it to character and put it in. Now, once I have that, I'm going to create my string. I'm going to say string my number equals new string, because I'm creating the string, and I'm going to throw in number. So now that I've done this, I have a 2000 digit number. And just to see what it is, I'm gonna print it out and say that my number and go see what this is. So let's see if it printed. Should have probably tested this earlier, but there is our 2000 digit number. Okay, so what we need to do is test every 14 to see what the total is. Now, this is one way to do it, which is you just take a character, um, uh, and you plug it in. Now, another way to do it would just be to use strings the whole time. So let's look at approach number 3. And the approach number 3 is going to use a string builder. So a string builder is not mutable. So that's kind of one of the problems. So if I just created a string and I just said plus a random number, then what will happen is plus a random character, that's going to have to rebuild it every time. So if I have string builder, and I'm going to say SB for string builder equals new string builder, and I'm going to put in here a string, which will just be a 1 to start with. And then I'm going to go up until 2000, and I'm going to start at position 1 because, sorry, I'm going to start at position 1 because that's where we want to be. And now the neat thing about a string builder, of course, is that my SB can have the function called append. And then I just need to get a rnd.nextInt and put in something 0 to 9, and then I'm able to do it. So in other words, it's going to just append a digit to this and then be able to build it. So if I go and print this out, this is going to be a string builder. So I'm going to have string SB string, and I'm going to say that string SB string is going to be, actually, let's call it, okay, we'll call it SB string, is going to be SB dot to string, and now it's going to convert it to a regular string because now I don't need the string builder because that just built it out, and then we can output SB string. So if we run this, we can test it and see if our SB string is good, and this is another random 2000 digit number, in this case starting with 1. So the point is that we use the string builder to add things to it, and we append the number, which it converts automatically because it makes the string, it converts it to the string, and it's just appending it as it goes, and then I'm able to build this out. Now, this is approach number 3. Approach number 4 is something that you would use if you needed to do like, well, I mean, if you needed to do less computing in a certain sense, which is that we're going to do our string builder again, but instead of doing my string builder, and here's approach number 3 that I'm going to take this string builder, sorry, my mouse is a little messed up, but I'm going to take my string builder, let's see if we can get this, okay. And I'm going to do this. I'm going to change the names, of course, because this is going to be a different approach, and this is going to be the SB big integer. So I'm going to call it SBI for each of these. So SBBI. And so this so far is the same, that I build it out with a string builder, but instead of making it a string, I can make it a big integer. And you may not have noticed this, but I added the library big integer over there. So I have big integer, and I'm going to call it BI for big integer equals new big integer. And this is an amazing library that SBBI that we have like this. So the reason why I'm using a big integer when it may seem, I need to do this, it may seem like I'm doing something that looks almost the same as before. And you can do this more directly with a big integer if we wanted to do this. But the reason why I'm using this, and we'll just test it out to print out our BI, our big integer. But the reason why I'm using it is because it's then I have lots of operations that are built in, things that I could do. So once it's a big integer, even though I convert it to a string, and you say, well, it's a string anyway, so why do any more? Well, because what if I want to multiply? How do I do that? Convert it to a big integer, and then you can do stuff like multiply, etc. So there's an awesome library called Big Integer, which allows you to create things that now we could use massively large numbers and do operations on them, and that's really the goal. So the point of this is that there's abstractions and approaches, And these are, okay, you can see most of these. These are different approaches to creating my 2000-digit number, which I would then potentially write to a file or something else like that. So this is the different approaches to the 2000-digit number. The next question is, now that we have our 2000-digit number, how do I go and then solve this problem, right? How do I go and solve the problem? So that I'm going to do in the next video.